Welcome to Lesson 13, Finding Equivalent Ratios Given the Total Quantity. This is a lesson continuing in Topic C, Ratios and Rates Involving Fractions. We will continue to use fractions in this activity, attempting to, in this example 1, to fill in the blank squares on the table you find below. Let's go ahead and read this example 1. A group of 6 hikers are preparing for a 1-week trip. All of the group's supplies will be carried by the hikers in backpacks. The leader decided that it would be fair for each hiker to carry a backpack that is the same fraction of his weight as all the other hikers. In this setup, the heaviest hiker would carry the heaviest load. The table below shows the weight of each hiker and the weight of his or her backpack. Complete the table. Find the missing amounts of weight by applying the same ratio as the first 2 rows. So let's go ahead. I'm going to scroll down before I put my annotating tool on. My black pen ready here. Okay, actually I don't want to do that. Let's go ahead and go back. I want to go up. Actually read this first again here. I want to look at this again. Always good to reread. I'm not sure if we all understand this quite well. Okay, so what we're doing here is that here's the idea. Okay, the leader of this group, a group of 6 hikers. Okay, he or she has decided that it would be fair for each hiker to carry a backpack that is the same fraction of his or her weight as all the other hikers. So, hopefully you understand what that means, but let me just go over it one more time. Okay, so what he's saying is that the way it'll be fair, okay, here's one thing. Okay, I am like a 190-pound man. I carry a backpack that's 50 pounds. All right. My wife is a 130-pound woman, not barely, 125-pound woman, and she carries, her backpack's maybe like 10 pounds. Okay, so that is not the equivalent fractions, okay, there, because she's carrying very, very little weight. I always carry more weight. Actually, this year, we just hiked to the top of Mount Whitney, and my son carried the most weight, and he's just a tad bit heavier than I, but he carried a bit more weight than I did. So anyway, it doesn't always work this way. It never works this way. But I'll tell you honestly, now that I read it here, it's not a bad idea. Okay, not a bad idea. So in this setup, continuing further here, the heaviest hiker would carry the heaviest load. What would also follow, the lightest hiker is going to carry the lightest load. Okay, so a hiker's weight as a ratio to the backpack weight, this ratio is always going to give us, and we should probably make another column over here, the same rate. Okay, so, whoopsie, boop boop, yikes, cancel. Same rate over here. In this case, our rate is going to be pounds, backpack pounds, backpack pounds to hiker pounds. Okay, so how many backpack pounds per hiker pound? Okay, we can do it that way. We could also do it the other way, which I don't know. We may start working with this and saying maybe we should make it hiker pounds per backpack pounds. But yeah, we'll see. Anyway, that's what we're going to do. We want to use these first 2, and why are we using these first two? These first 2 hikers. We're using those two because they supply us with the data that we need to come up with the rate. Okay, because we need this rate. Because what we're going to do with that rate is that we are going to apply this rate, which these two should be similar, okay, because that's what this leader wants. We're going to apply this rate, this constant rate, to all the other scenarios, okay, to all of the other scenarios, and we'll watch that play out. But let's go ahead and figure out this the rate here, okay. First thing we need to do, and again we've done this in the past, we've done this for the last few lessons. We are again talking about weight, as we came to realize last class session, that many of us did not know how many ounces to a pound. Okay, hopefully that is something that we all know now and will embrace forever after. 1 pound equals 16 ounces. Okay, and of course we have abbreviations: ounces, OZ; pound, of course, LB. I'm saying of course, I'm not sure everybody knows that, of course, but hopefully you'll come to learn these things and know these things better as we move through all of these lessons. Okay? Keeping that in mind, and again, we've talked about this before, let's go ahead and turn our weights here, our respective weights, into fractions. So hiker's weight here, let's not call it 152 pounds 4 ounces, let's say 152 and 4 over 16, which we know is the same as, let's go ahead and do that and reduce that, simplify that to 1 over 4. Because 4 out of 16 is the same as 1/4. And over here, instead of backpack weight, we have 14 pounds 8 ounces. We know what we can do with that. We can make that 14 and a half. Okay, 14 and a half. So let's go ahead and move ahead in the slideshow, and let's go ahead and do this here. Let's go ahead and do this. So move ahead. Let's go ahead and make a whiteboard. Okay, and I think, what do we have? We had 14 and a half over, let's go back, 152 and 1/4. 152 and 1/4, because we are getting backpack weight per each pound of hiker weight. And again, this could work the other way, and as I'm looking at it, it sure looks like it might be a little bit. I like it when the number's bigger on the top, usually the numerator. But anyway, let's work with this. Okay, so 14 and a half. Again, you remember what we do with this? We are making these into our improper fractions. 28, that's 29 halves. Yeah, I'm not going to continuously say how we get these, how I'm doing this conversion. I'm hoping you're understanding. Okay, now 152 and 1/4. This is going to be a biggie. 152 times 4. I'm trying to get how many fourths in 152. What is that? 608. Is that right? 608. Well, actually 609. Because no. 608, and then a 609 because I have to add this one I have here already. So 609 fourths. Okay. Here's my division problem. Looking kind of ugly, huh? But anyway, let's go ahead and do that. We know what to do with this. 29 over 2, and again we're multiplying now by the reciprocal of this bottom. Okay, so that's going to be of our denominator, 4 over 609, okay, equals, okay, so let's see, we have, take these two away here, we can do division or cross division here. This is going to be 58 over 609. Now, I'm going to go ahead and let you use a calculator. Okay, I'm going to use my calculator right now and do this division, and as you can see, it's going to be a fractional answer. okay, because we know it's going to be a fractional answer because our numerator is less than our denominator. Okay, so the way I do this, of course, like any fraction, is 58 divided by 609 equals. So then if this equals as a decimal 0.0952381, okay? All right, so I want to round that. I'm going to round that, so if I do go ahead and round, I'm going to round it to this tenths place. So we are looking at 1/10 of a pound. Okay, so for every pound of hiker weight, we are going to have them carry 1/10 of a pound in their backpack. Okay, you can see how that works. What I did here. If we flip that over and did it the other way, let's go ahead and do that. So let's see. So see, in this case, it's again the way we set it up was we set it up with hiker's weight being our x and backpack weight being our y. Therefore, we again always having y as y as a function of x. Okay, this does not have to always be this way. Okay, certain cases, yes, very, very clear. But in this case, we could have turned that around. And if we did turn it around, let's go ahead and we have a new whiteboard. Let's go ahead and put 152 and 1/4 over, remember, 14.5. Okay, I just wanted to convince you. And again, let's just get we got of our own numbers. We have all the same numbers here. 609 over 4 over, what was that, 29 over 2. And so we have 609 over 4 times 2 over 29. Boom, boom. 1, 2. Now we have 609 over 58. And you can see how this is just the opposite of that, because we're flipping our numerator and denominator now over here. Okay, just want to keep clearing that up with you. See how we put actually hiker weight on top as our numerator and backpack weight as a denominator on the bottom. Okay, so now dividing 609 divided by 58. It's going to be a little bit more, a little prettier kind of operation here. So we do 609 divided by 58. We get 10.5 actually. Okay, so we get 10.5, which is a little bit more elegant to work with. 10.5 versus 1/10 of a pound. So in this case, which is different. So right here, we were saying for every pound of backpacker weight, we had 1/10 of a pound in the backpack they carry. I'm sorry, this should be hiker down here. I'm sorry. So again, every 1 pound of hiker weight, they would have 1/10 of a pound in their backpack. Okay, so you can see how that works. So this 1/10 of a pound per pound of hiker weight. Here, we're looking at 10.5 pounds of hiker weight per pound in the backpack. Okay, it's neater in this sense, but this one makes more sense because, and maybe you're thinking about this yourself, the thing that we know, we're going to know someone's weight. Okay, so we know their weight. All right, we don't know what they're putting in the backpack yet. Okay, how much we're going to give them, because that is always going to be based on how much they weigh. Okay, so you see what I'm saying? So this truly is y as a function of x, because the pounds that they put in their backpack is going to be a function of how much they actually weigh themselves. So in reality, this makes more sense within the problem. This makes it a little easier to do, especially in this case because we have all these figures already, okay? And what we're doing here in this case is we're just filling in a table, okay, right here. So we know that this one here is 10.5. That's our rate, okay? Or I'm sorry. Well, what are we going to do? We're going to do 10.5. We're going to do 1/10. Let's do 1 to 10. Let's do 1/10, or 1 to 10, or 1/10. Okay. All right. So total weight here. Now, when we add these two up again, right here, this 152 pounds 4 ounces, 14 pounds 8 ounces. This is this is a pretty easy one here. So we have 166 pounds and 12 ounces. But 12 ounces is 12 over 16, our fraction. Okay, so we're going to do that. It's going to be 3/4. So this is actually, and again, we could do either one. So it's asking us here for pounds, so we're going to put it in pounds. So the total weight is 166 3/4 pounds, also known as 166 pounds 12 ounces. Okay. Down here, we know this is going to be constant. Go ahead and do this one if you want to, okay, and see if it's consistent. I'm going to tell you that it is. So we know, again, this is 1 to 10. All right, we add this up, and what do we get? We get 117 pounds, 14 ounces. And then if we just go ahead over here and put 14 over 16 and make that as simplify that as much as we can, we get what, 7/8 of a pound. So 117 7/8 pounds. That's what this is right here. Okay, 1 to 10. All right. Okay, so before we apply this rate to the rest of the table, I want to just correct myself a bit, and I want to apologize for not being as precise as I should have been. Way back when I originally did this one, which is the one that applied most correctly, what I should have done is I should have actually been a little bit more strict to this number here, and not have rounded so quickly. Okay, this is the danger of rounding. I rounded up to 1/10, but we should use this that 9.5. So or 0.095. So if I go ahead here, and I did go ahead and then recalculate, and if you had actually done that, put as a fraction 58 over 209. I mean 58 over 609, like we had. This would actually be 2 to 21. Okay, 2 over 21 would have been the fraction. It would have been like this. So the fraction you would have gotten if you divided, 58 divided by 609. Okay, that's equivalent to 2 over 21. Okay, so 2 to 21, 2 to 21. So these should be 2 to 21. We're going to just take those off. That was my rounding. A little bit of a rounding. I'm going to say error, but a little bit of a rounding. You can see how rounding complicates things and makes things less precise. So probably not a good thing to do in this case. Okay, so if we go ahead and do apply, take this away here. So if we do apply our fraction, which is our rate, 2 to 21 or 2 over 21, to let's go ahead and do that with 129 pounds 15 ounces. Okay, let's go back here. Okay, so 129 pounds 15 ounces. Pounds 15 ounces. All right. So this is our hiker's weight, and our hiker's weight, if you remember, is our X. Okay, let's go back here again. All right, hiker weight right here is our X. In this case, was 152 and 1/4. Here we're looking at 129 pounds 15 ounces. 129 pounds, 15 ounces. Now, 129 pounds, 15 ounces is also, of course, 129 and 15 sixteenths. Okay, so that times the rate, which we know now as 2 over 21, will give us our y, because we go back to our equation from a long, long time ago. If you do remember, y equals r times x, r being a rate, a constant of proportionality. Okay, so we need to go ahead and multiply 2 over 21 times this number here. Let's do our thing that we know how to do. Again, please, these are big numbers. Feel free to use a calculator to, multiply 129 times 16. For example, I'm going to do that right now. 129 times 16. That equals 2,064. Then I'm going to add another 15 to it. Okay, so that's going to be 2,079. So 2,079 over 16, that is this number made into this mixed number made into an improper fraction. And then 2 over 21, I will just leave alone. Okay, and we're going to multiply these. Okay, there's no reciprocal here. We haven't done any division. Okay, we're doing this. So here we could just take care of this. That becomes 1. That becomes 8. So I'm dividing both of those by 2, finding a common factor if I can. I'm going to go ahead and just take a chance to see if I can divide 2,079 divided by 21. And let's hope. And we got lucky. Well, not lucky because they made sure this was going to happen. So if I cross-divided here or cross-canceled, I could divide actually 2,079 divided by 21 is actually 99, believe it or not. Okay, so 99, and we have 1, so 1 times 99 is 99. 1 times 8, 8. Okay, and now I have this I can work with, which is very nice and neat. And if I divide 99 divided by 8, that will equal 12. I'm doing that 12.375. 12.375. And I want to go ahead and get my ounces there. So if I do 0.375, let's see, so 3, 5, okay, all right. So we are going to get 12.375 as our backpack weight. So this person who weighs 129 pounds and 15 ounces, if they apply our rate of pounds of how many pounds in the backpack per pound of weight, they are going to have to carry 12.375, which, we'll go back here and fill this in, 12.375, which is actually 12 and 3/8 pounds, which is 6 ounces. That's right, yeah, 12 pounds. 12 pounds, 6 ounces. Okay? So we do 16 times 0.375, and we get 6. Okay? So 12 pounds, 6 ounces is going to be our backpack weight there. Total weight, we just add those together. See, we're going to have, we add our ounces, we get 21. We can only use 16 of those for another pound. So what is that? That is going to be 130, 142, 142 pounds and 5 ounces. 142 pounds, is that right? 5 ounces? Because we had 20, yep. 142 pounds and 5 sixteenths. 5 sixteenths of pounds. Okay, so 142 and 5 sixteenths pounds. Again, we're looking at just doing pounds here, okay? And again, your rate is still 1, oh, it's not. What happened here? We need to cross because we know now that this is actually 2 to 21. 2 to 21. Sorry, I got a rate 2 to 21. Looks like I filled in the wrong table here. Okay, so let's, where was that other table? Oh, here it is. Okay, help me out again here. What do we get for this? We got 12 pounds, 6 ounces, and this was 142 and 142 and 5/16 pounds, and then again this is 2 to 21. Okay, so I went ahead and filled in this one here, the next hiker right here, whose weight was known, and again applying all the same rules, same equations as we did here. I came up with these answers. You can check those. I'm not sure, be a little bit off. I got 6 pounds 8 ounces here. A little bit different because I didn't include every single decimal in the 0.95 blah blah blah. But anyway, I think these are correct. Okay, pretty darn near correct anyway. Okay, now we're going to go ahead and do these now because these differ. I'm only going to do this one, and then I'll let you go ahead and do this by